Hello dear learner, welcome back to the Zoom Chemistry app. Today with another interesting video in which we will discuss and learn what is mole fraction and how the sum of mole fraction of all the component becomes equal to 1. So first, what is a mole fraction? Mole fraction is defined as the ratio of number of moles of one component to the total number of moles of all the component present in a solution. Mole fraction is denoted by capital X. For example, if we have Na is the number of moles of the solvent and Nb is the number of moles of the solute, and similarly and Xa is the mole fractions of the solvent and Xb is the mole fraction of the solute. Then the total number of moles are equal to, that is, the total number of moles of this solution is denoted as Nt, and Nt is equal to Na plus Nb, and the mole fraction of the solvent is equal to Xa is equal to Na divided by Nt. Similarly, the mole fractions of solute, that is equal to Xb, and this is equal to the number of moles of solute, that is Nb divided by total number of moles, that is Nt. Now the sum of the moles fraction of all the component of a solution is always equal to 1. How? We know that Xa and Xb are equal to Na divided by Nt plus Nb divided by Nt. Now we will take the LCM of this. So we get Na plus Nb divided by Nt, and at the above, that is Na and Nb are equal to Nt. So at the numerator we get the value, that is Nt, and at the denominator we have already the LCM is Nt. So both these cancel each other, so we get 1. So the sum of the mole fractions of all the component of a solution is always equal to 1. We know that mole fraction is independent of temperature. Concentration of more than one solute can easily be expressed by this method. Now we have an example in which we have to find the mole fractions. The example is that a solution contains 2 moles of alcohol and 3 moles of water. Calculate the mole fraction of alcohol and water. So we have to solve it. First, the number of moles of alcohol, that is equal to 2 moles, and the number of moles of water, that is equal to 3 moles. Now the total number of moles of both the component, that is 5 moles, that is the number of moles of alcohol, that is 2, plus the number of moles of water, that is 3, and the total number of moles of the solution, that is 5 moles. And the mole fraction of alcohol we have to calculate first. So the mole fraction of alcohol is equal to the number of moles of alcohol divided by total number of moles of the solution, and we have that the number of moles of alcohols are 2 and the total number of moles of the solution, that is 5. So after calculating this we get get the mole fraction of alcohol, that is 0.4. Similarly, the mole fraction of water, that is number of moles of water divided by total number of moles of solution. We have already calculated the total number of moles of solution, that is 5. So the number of moles of water, that is 3, divided by the total number of moles of the solution, that is 5. So we get the mole fraction of water, that is 0.6. As the sum of the mole fraction of all the components in a solution is always equal to, that is the mole fractions of alcohol plus the mole fractions of water, and the mole fractions of alcohol are equal to number of moles of alcohol divided by the total number of moles of the solution plus number of moles of water divided by total number of moles of the solution. And we put the value, that is 2 divided by 5 for alcohol and plus 3 divided by 5 for water. Now we take the LCM of this and we solve it mathematically, then we get the answer, that is 5 by 5, and 5 by 5 cancel each other and we get 1. So the sum of the mole fraction of all the components in a solution is always equal to 1. So in this example and in this way we can find the sum of the mole fraction of all the components of a solution is always equal to 1, and the mole fractions of the component. That's for all today, the learner. If you like this video, please like, subscribe and share with your friends and fellows. Thanks for watching.